Okay, in this video, I will give you we are going to give you the answers and explanations to the expression questions with variables included. Okay, so let's see that. Okay, so we are basically giving you the solution and explanation about the previous video, the questions on expression with variables. Okay, right. So let's go through that. Okay, these are the variables we are looking at, and for our expressions to solve, we are going to use these variables. So basically, x is, we can consider it as a numeric variable. For our exercise, we will consider it as numeric variable because x can even be an alphanumeric variable. Okay, because numbers, the two types of variables, numeric variables and alphanumeric variables, the major difference is in the numeric variables you can only store numbers which can be manipulated with arithmetic operations. You can add, subtract, average, get the average, and so on and so forth. Okay, so get the total. That's for numeric values. Alphanumeric values you can't do arithmetic operations with, right? So, but if you look at the two types of variables, numeric variable and alphanumeric variable, even in the alphanumeric variable, there is a numeric part. So that's why I said 25 can also be stored as alphanumeric under an alphanumeric variable. But then it won't be a number. It will be just like a house number or whatever, where you don't do any arithmetic operations with. So if you keep your numbers in an alphanumeric variable, then those are not numbers as usual numbers. Okay, they are going to be considered as just some kind of a code, and therefore you can't do arithmetic operations with that. You can't add, subtract, divide, multiply, average, total. None of those can be done. So that is the main difference between the numeric variable and numeric, not only variable, numeric data type and the alphanumeric data type. Okay, so in this example, I am assuming x is a numeric variable, even though it can be an alphanumeric variable, but for our exercises, we are going to consider this as a numeric variable, okay? And age also we are going to consider as a numeric variable. Now, y and gender cannot be numeric variable because it contains some alphabetic characters. Now, in this case, you get Linda inside y, and inside gender we have female. So these two, y and gender, are alphanumeric variable, otherwise you can't keep. That is not possible. So basically x and age we are going to consider as numeric variable so that we can do arithmetic operations with that, and we are going to y and gender are alphanumeric variables. So x contains 25, y contains the word Linda, age contains 37, gender contains female. So x, y, age, gender are all variables. Okay. Here we have another variable called phone no to store the phone number. This variable name is phone no. Okay. So we'll say phone number. Okay. Now phone number, basically remember numeric or alphanumeric variable, the variable will be based on what you actually store in there. Now this is a number, all of them are numbers. So we can actually store this as a numeric. Then phone number will become a numeric variable. But the problem is why we are storing phone number as an alphanumeric variable. First reason is phone numbers you will never want to add or subtract or multiply. You don't do any arithmetic operation. That is one of the reasons. But one of the main reason is if we store this as a numeric, then this leading zero will go off. I think I explained this earlier also. Even if you put 0, 0, 5, 5, 5, 4, 4, 4, 3, 3, 3, the two zeros will be lost. Now in this case, I put 1 0 in front, the 1 0 will be lost. Because in a number, if you say, for example, 25, or 025, or 0025, or 00025, or 00000 and 25, whatever it is, it's 25. All the leading zeros don't make any sense. So it does not store the leading zeros. Leading zeros means the zeros that come in front. Okay. If there's a zero in the middle, that is important, okay? But I'm talking about any zeros on the leftmost sides, the leading ones. So in this case, we want to store a phone number, and let's assume this phone number starts with a 0. Then if we store it as a alphanumeric under an alphanumeric variable, then this 0 will be lost, and next time we look at it, what we will find is 555 444 333. So that is the reason why we are taking this phone number as an alphanumeric variable and we are storing this. Okay, so if you have any leading zeros or dash or anything else you want to include in that as the content, then we need to store in alphanumeric variable. Only numbers can be stored in numeric variables. So once again, X, Y, age, gender and phone no are all variable names. So these are the variables. And the contents of the variable is 25 Linda, 37 female, 0555 444 333. Okay, those are the contents of those variables. Now, why are these called variables? Because X can keep 25 or 35 or 95, it can keep different numbers. Same way Y can keep different things here. Age can keep different things here. Gender can keep different things here. Phone no can keep different things here. So the name won't change, but the contents of that can change. So therefore, these variables are called variables. They can change. X can change. It need not be always 25. If you put 35 there, it will be 35. Same goes to all these other variables. So the variable names are X, Y, age, gender and phone number. Phone no. The contents are 25 Linda, 37 female and 0555 444 333. Okay, and we know exactly where each one is stored because we have put that under that name. So under Y we have stored Linda. So like that, these are the variable assumptions. Okay, right. Now let's go to the first exercise, this one. And from our BODMAS rule, we know when you have a minus and a division, division needs to be done first, right? But here we have 35 and 5, both are numbers, numeric constants, but X is, we don't know. What exactly is this? This is, we are referring to this X. Okay, if there is double quotes around it, then we are talking about X itself. So we will come to that in a minute. So here we have one variable called X and divide by 5. So according to the BODMAS rule, we have to do the division first. So we will be, first before we do the division, let's substitute the value 25 for X in this case. Right now it is 25. If this X had 35 now, then we have to substitute with 35. Okay, if it had 45, we have to substitute it with 45. But for our example, we are assuming X is 25. So we substitute that. So X, we put that. And the rest of the formula, we write that. So 35 minus, we have, in place of X, we have put 25 because X contains 25 and divided by 5. So when you have an expression like this with variable, first thing you have to do is substitute the variable with the contents of the variable, like this. So now we know division has to be done first. Okay, so according to BODMAS rule, minus and so, and we have basically numeric expression now. 25 divided by 5 is 5. Then we have 35 minus, so 35 minus 5 is 30. So the answer to this expression, assuming the variable X contains 25, is 30. So we are assuming this, okay? If this was a different value, then this result also will differ. Okay, so just remember that. Now let's go to the second one. Now in this case, we have to do this bracket first. Why? Because brackets carry the most highest priority even before the division. Okay, so before we do anything, let's substitute. X is 25. That's the assumption we are taking now here. X is 25. So we put 25 there and the rest of the formula is that. So here within brackets 35 minus X. So instead of X we have put 25, which is the contents of this. Okay, close bracket. Then we have divide by 5. So divide by 5. So now we have a numeric expression with numbers straight away. So this is basically what we have to do. So now in this case we have a division, but before that we have a bracket. Bracket carries the highest priority, so we have to do that first. So when you do that, that is 35 minus 25, which is 10. Then we have divided by 5 as the rest of the things. So now this is what we have to do. 10 divided by 5. So 10 divided by 5 will come to 2. So the answer is this. So if we have an expression like this, open bracket 35 minus X, close bracket, divided by 5, and if X contains 25, this is the answer. If X contains some other value, this obviously will differ because you have to substitute with that particular value. For example, if this was say 95, then we put 95 here and do the expression. Okay, just remember. So this is our B question. Then the third one.